Hello, welcome back to KISH-CAT classes. In the previous two sessions, we have learned concepts related to Chinese remainder theorem, least common multiple 1 and least common multiple 2 methods, as well as constant remainder theorem. In fact, Chinese remainder theorem is normally known as LCM method 3. And also we have solved many examples for all these concepts. Now this is the video related to solutions of CAT questions, that is these four concepts asked in the CAT examination in the last 25 years. I suggest you to solve all those questions and then watch this video. You can find the worksheet for this particular video. You can find the worksheet in Facebook page of KISH-CAT classes. First I move to question number 1. What is the smallest number which when increased by 5 is completely divisible by 8, 11 and 24? Now n is divisible by 8, n is divisible by 11 and also n is divisible by 24, but the remainder is 0. It means n we can take it as 8x, n is of the format 11y, n is of the format 24z. Now how can we find this number? Is quite simple. The remainder is 0, so the simple thing is first remainder, that is a remainder, plus LCM of divisors into constant, because this number is of the format. Now the remainder is 0. Now LCM of divisors, that's 8, 11, 24k. So this is nothing but 8, 11, 24. So we just need to find it. This is the number is of the format 264k. The LCM of 8, 11, 24. Now this is the number. So if k equal to 0, so the number is going to be 0. If k equal to 1, so the number is going to be 264. Now they ask us to find the smallest number. Smallest number is like, you can directly take the number as 0. N is 0, that's possible. Smallest number which when increased by 5. So it means smallest number is 0 when increased by 5. So the number would be 5 itself. However, we can directly say, if you want to find a non-zero number, so that means it is 264 minus 5. That means it is 259. So 259 when increased by 5, the number would be divisible by 8, 11 and 24. If they ask us to find how many 4-digit numbers are there and all, so then we just need to follow the number pattern, which is 264k. Let's solve next question. Which is the least number that must be subtracted from 1856 so that the remainder when divided by 7, 12 and 16 is 4? So here when a number is divided by 7 and the number is divided by 12 and when the number is divided by 16, the remainder is 4 here. When the remainder is 4, it's quite simple. The number is remainder, that's what we have learned, plus LCM of divisors. Here remainder is 4. Now the LCM of 7, 12 and 16. That's what we need to find. So that's going to be 4 plus 336k format. Now this is a number which is closer to 1856, but we need to subtract some number from 1856. So in such a case, what we can do is like, it's 4 plus 336 into some number, that's 5. That will give us 4 plus 1500 plus 180, 1680. So the number must be 1684. However, the number is given is, it is 1856. So we must subtract some number from 1856 so that the number is going to be 1684. So we just need to subtract 172. So if we subtract 172 from 1856, we are going to get a number 1684. That is of the format remainder plus LCM of the divisors into constant. Let's solve question number 3. Now This is a word based one. 3 bells chime at an interval of 18 minutes, 24 minutes and 32 minutes. At a certain time, they begin to chime together. What length of time will elapse before they chime together again? It's quite simple. It's given that first one will chime at 18 minutes, second one 24, third one 30. So what we can do is like, let's say bell 1, it's going to take place at 18, then the next one is going to be 36, next one is 54 and so on. So this is the format 18x. Bell number 2, it performs at 24, 48, 72 and so on. So this is like 24y. Now the next one, final one is bell number 3, that takes place at interval of 32, that's going to be 32, 64, 96 and so on. That's going to be 32z. So we just need to find what is the common term of all these arithmetic progressions. Now, since we have no idea about what is the first term here, what we can do is like, we can say that we can extend the first arithmetic progression in the other side, that is like 18, 36, 54. What would be the term before 18? That's going to be 0. What would be the term before 24? That's going to be 0. That's going to be 0 here. So we can say it's 0, that's the first common term, plus LCM of time, that's going to be 18, 24 and 32. That's it. 18, 24 and 32. That's going to be very easy. So we just need to find the LCM of these numbers. That's anyhow, we can find it by taking factors, or we can find it by taking a thing that we have learned in the school stage. So it's going to be 4, 4 sixes, 4 8s. Now we can take any number. 3, then 3 sixes, 3 twos and 8. Now we can take 2, then that's going to be 3, 1 and 4. So 4 3s are 12, 12 2s are 24, 24 3s are 72, 72 4s are 288. So it comes at 288 minutes. 288 minutes is 4 hours 48 minutes. Or else we can take the factors, that is 18 can be written as 2 power 1 into 3 square. The next one 24 can be written as 2 cube into 3 power 1. 32 is nothing but 2 power 5. Now all the prime numbers, 2 is presented and 5 is present, 3 is presented, that's it. What is the highest power of 2 presented? That's 5. What is the highest power of 3 presented? That is 2. So that is 2 power 4 into 3 power 2. That's it. So this is the one we need to. So 2 power, that is going to be 32 into 9. So that's going to be 288. Either we can take this one or we can take this one. Now the LCM is nothing but, if you need to write every single number, that is every single prime number, that 2 is presented, 3 is presented. So now what is the highest power of 2? That is power 5. What is the highest power of 3? That's power 3. So this is going to be LCM. On the other hand, if you want to find the HCF, highest common factor, you just need to take every single prime number presented. That's going to be 2 into 3. What is the least power of 2 presented? So least power is 1. What is the least power of 3 presented? That is 0. 3 is not there in 32. That's going to be, it's like into 3 power 0. So 3 power 0. So that means it's going to be 2. So HCF is 2, LCM is 288. Let's move and solve the next question. 3 wheels complete 60, 34 and 26 revolutions per minute. There is a red spot on each wheel that touches the ground at a time 0. After how much time all these spots will simultaneously touch the ground again? Look at this one. It takes 60 revolutions per minute. It means we just need to, okay, second one takes 36 revolutions, third one will take 24 revolutions. Look at this here, the revolutions are given. We cannot take the LCM of the revolutions. We need to take the LCM of the times. So it means 1 minute, that is first one, let's say wheel 1, that is 60 by 60. It means that it will take 1 second per revolution. Now wheel number 2, it takes exactly 60 by 36. That means it's going to take 5 by 3 seconds. Wheel number 3, that's going to be 60 by 24 revolutions. It's going to take 5 by 2 seconds. Now when will they touch together? That's very simple. We just need to take the LCM because it runs for every 1 second. So we can say wheel 1 for second, third, fourth, and so on every second. Wheel number 2, then we can say 5 by 3. The next one is going to be 10 by 6. Next one is going to be 15 by 10 by 6, 15 by, no, it's 10 by 3, it's not 10 by 6, 15 by 3, and so on. If we just want to convert them into proper fractions, then we can say 5 by 3 is nothing but 1 2 by 3, 10 by 3 is nothing but 3 1 by 3, 15 by 3 is nothing but 5, and so on. Now the second one is going to take it every 5 seconds, 5 by 2 seconds, not 5, 5 by 2 seconds. So in such a case we can say 5 by 2, the next one is going to be 10 by 2, next one is going to be, and so on, that's going to be 15 by 2. So if we convert them, that's going to be 5 by 2 means 2 1 by 2 seconds, 5 seconds, 7 1 by 2 seconds, and so on. What is the first common number here? Obviously 5, here 5, and here 5. 5 is the first common one, so it's going to touch at 5 seconds. This is a very simple one. The advantage that we are getting here is now we can find the first common term quite easily once we start writing them in arithmetic progression. But what really happens if we have to write so many terms of every arithmetic progression to find the first common term? That's going to take a lot of time. Instead of it, we can have the same thing. That's like we can find the LCM of 1, the LCM of time, that is 1, then it's 5 by 3 and 5 by 2. Now, how can we find the LCM of fractions? Is quite simple. Whenever you want to find the LCM of time, LCM of a fraction, that's going to be LCM of numerator, whereas we need to find HCF of denominator. Whatever we want to find, if you want to find LCM, then we need to take LCM of numerator and the reverse, that is the HCF of denominator. If you want to find the HCF of this number, then we need to find the HCF of numerator and LCM of denominator. That's it. Now here, first one we can write it as 1 here, 1 by 1. Now what is the LCM of numerator? That is 5. HCF of denominator is 1. So 5 by 1, that's going to be 5. So it will take 5 seconds. So let's move to question number 5. A red light flashes 3 times per minute. A green light flashes 5 times in 2 minutes at regular intervals. If both lights start flashing at the same time, how many times do they flash together in 1 hour? It's in 1 hour. So we need to find the number of times. It's not that the first time, we just need to find the number of times. So a red light flashes 3 times per minute. So it means 60 seconds by 3 times. That means that each one it's going to happen at 20 seconds. That means it's at 20 seconds, 40 seconds, 60, 80, 100, 120, and so on. The second one is like 5 times in 2 minutes. That means that 120 seconds by 5 times, that's going to be 24 seconds. So it means it's going to be 24, 48, 72, 96, 120, and so on. Now it's here the first common term, we can find that it's 120. 120 seconds means that's what we can find quite easily. But it's not the question is not about when they perform together for the first time. They have asked us to see how many times do they come in a particular period, that is the period is 1 hour, that is 3600 seconds. Now the first one is 120. Now we can easily say that before this 20 it's going to be at 0, before this 24 it's going to be at 0. Now what we can do is like either we can take 0 as the first time they flash together, or we can say that 120 seconds they flash together. That means that the gap is 120 minutes, 120 seconds. It means that every 2 minutes they come together. In 60 minutes we can say 30 times, or else we can say 120 plus LCM of times, that is 20 seconds and 24 seconds into constant. That's going to be 120 second plus LCM of 20 and 24 is 120 second into K. That's it. If K equal to 0, it's coming together. So K can take a maximum of 19. So K from 0 to K 19. So that's 20. That's very easy actually. We just need to take the LCM of the times so that we can find when they occur simultaneously. Let's move to question number 6. At a bookstore, modern bookstore, modern bookstore is flashed using neon lights. The words are individually flashed at intervals 2.5 seconds, 4.25 seconds, and 5.125 seconds respectively, and each word is put off after a second. The least time after which the full name of the bookstore can be read again. Look at this one. What is this? 2.5 seconds, 4.25 and 5.125 seconds. Which one? Modern is 2.5, book is 4.25, and this word called story is 5.125 seconds, and each one it's going to take 1 second longer. So it means the whole thing will again appear. Let's say it started now at 0 second. Then when will they come is like from 0 to 1 second it's on. Then we need to give a gap of 2.5 seconds. It means that it starts, let's say first one starts at 0, then it's up to 0.1 second, that is on. From 1 second to again 3.5 seconds, that is off. Again it's going to on at 3.5. So look at the gap. The first one occurs at every 3.5 seconds. Second is the same is the case. 0 to 1 on, then it's 1 to 5.25 off, then it again started 5.25. So the gap is 5.25. Third one is the same, 0 to 1 on, let's say 0 to 1 on, then from 1 to 6.125 it's off. So again it started 6.125. So it means that the gap for the first one is 3.5 seconds, gap for the second one is 5.25, gap for the third one is 6.125. So we know the time intervals. Now we just need to find the LCM of these numbers. So we can convert them. This is going to be 7 by 2. This is going to be 5 1 by 4. That means it is 21 by 4. This is going to be 6 1 by 8. 125 is 1 by 8. 6 1 by 8. That's going to be 49 by 8. So we need to find the LCM of 7 by 2, 21 by 4, and 49 by 8. What we need to do is LCM of numerator and HCF of denominator. What is the LCM of numerator? 7, 21, 49. That's what we need to find. If we can find 7, 21, 49, we can say it's 7 ones are 7 threes, 7 sevens. So that's going to be 7 into 3 into 7, 49 into 3, 147. So that's going to be 147 by HCF of 248. That's going to be 2. So 147 by 2. That's going to be 73.5 seconds. So every 73.5 seconds, we can see the modern bookstore. Every word is on. Look at this one. From question number 4 onwards, we have been solving the same kind of questions, but question number 6 is a very new pattern one. Do remember? It's on and off. So we need to find on plus off, the total duration as the duration or as the difference between two consecutive terms of every single word here. Let's move to question number 7. The number of common terms in two sequences. This must be very simple. What we have done in the previous two things is like we had to write the sequences, then we had to find the common terms. Here the sequences are given. Quite simple, two sequences. 17, 21, 25 and up to 417, 16, 21 to 26 and up to 466. So we need to find the number of common terms. How can we find is, first we need to find the first common term, then that's going to be simple. Here the progressions are 7, 21, 25 and up to 470. Next one is like 16, 21, 26, and so on up to 466. Now you can see that first common term is 21. So first common term plus LCM of divisors. What is the divisor here? That is the most important one. The divisor is nothing but the common difference. So here the common difference is 4 here. Here the common difference is 5 here. So it means LCM of 4 and 5 and it's into K. That means 21 plus 20K. K equal to 0, the first term. First term when K equal to 0. So we need to find the nth term. K equal to what? But do remember, nth term cannot be more than 417. It has to be less than 417. Then we can say it's 21 plus 20K is less than or equal to 417. We can say 20K is less than or equal to 396. So K can take a maximum of less than or equal to 19. So K value is going to be 19. So, but K is starting from 0 to 19. Do not simply say that it's 19 terms actually. Look at that one answer option carries 19. That is the dangerous one. You must be extremely careful here. The terms start from K equal to 0 to K equal to 19. 20 terms. Yeah. So the two things that you can learn, one thing you can learn, not two things, one thing you can learn is the LCM of the device that we need to consider. Here the divisors are not given. However, the common difference is going to be the divisor. Next one, you are supposed to be careful and you need to understand the range. First arithmetic progression, nth term, last term is already finalized, that is 470. Second one is 466. It means after 417 we cannot take common terms. So careful here. The integers, let's solve next question, that is the integers 34041 and 32056 when divided by a 3-digit integer n leave the same remainder. What is the value of n? Now we have got a number 32506. By a particular divisor d, the remainder is same as 34041 divided by d, the remainder. So both the remainders is constant here. Constant means it could be any number. When will they happen? It's quite simple. So it's very easy here. We can say that these are the terms of these are the terms of an arithmetic progression, one arithmetic progression, and we can easily see that this just like that constant remainder theorem application. What is a constant remainder theorem? I taught you that 10. Let's take 24, 38, 52, 66, 80, 94 and so on. Let's say these are terms of an arithmetic progression. Now common difference here is 14. Now when we divide 10 by 14, remainder is same as 24 by 14, remainder is same as 38 by 14 and so on. Or else we can take the factors of this number. The factors of 14 are 1, 2, 7, 14. Now by 1 the remainder is going to be 0. By 14 the remainder we already found that it is 10. By 2 the remainder is going to be 0 because all the numbers are even numbers. Now by 7 we can say 10 by 7 remainder is 3. 24 by 7 remainder is also 3. No, just let. Yeah, 24 by 7 remainder is also 3 and then same as 38 by 7 remainder is also 3. Now if we take common difference, if you are trying to divide every number by the common difference, the remainders are going to be equal and they are constant. When we take the factors of the common difference, again when we take one particular factor of the one of the factors and then try to divide every number, we get reminders which are equal, which might not be equal to the first remainder. The first remainder here is 10. But when we divide by 7, the remainder we are getting 3. But remainder we get 3 for every single term here. Now that we can apply here. Now imagine that these are two terms of an arithmetic progression. Now we can see that common difference. We can see the difference between these two is the common difference. That is 34041 minus 32506. That is going to be 1535. Now 1535, when we try to divide these two numbers by 1535, we get the same remainder. Or else, when we take the factors of 1535, we get the same remainder. Now, instead of trying to find the factors of 1535, you can just check the answer options and then try to see which one of them is going to be the factor of this number. Now, if you check any number, that's going to be 289 into 5, or we just need to into 5. Into 5 can't be 1535. 367 into 5, because the number is supposed to end with 5, so we need to multiply the number with 5. 367 into 5 is excess of 1535. 453 into, we just need to multiply 5, that's going to be excess. So 307 into 5, that's going to be 1535. Now we can say that 3250 by 307 as well as 34,041 by 307, we get the same reminders. Look at this one. We just applied a remainder theorem, that is constant remainder theorem. Let's move to question number 9. Number of students who have opted for subjects A, B and C are 60, 84 and 108 respectively. The examination is to be conducted for these students such that only the students of the same subjects are allowed in one room. Also, the number of students in each room must be same. What is the minimum number of rooms that should be arranged to meet all the conditions? Look at this one, it's a word based question. We just need to convert them into a simple question so that we can apply either least common multiple 1 or 2 methods, or Chinese remainder theorem, or constant remainder theorem. Whatever here asked is quite simple. We have got section A where it is 60, B is 84 and C is 108. Now we need to find a number that is we need to find two numbers. One is rooms, number of rooms, and then a capacity of each room. Now the capacity of each room must be same. Absolutely. And also what we need to find is, let's say if we have got, let's say 10 students sitting in a particular room. So section A we can accommodate in 6 rooms. But section B we cannot accommodate in 6 rooms. So we need to accommodate in 8.4 rooms. That is not possible because every room should be filled completely. That's it. Now, in other words, what we need to do is quite simple. 60 by D, the remainder must be equal to 0, as well as 84 by D, the remainder must be equal to 0, and then 108 by D, the remainder must be equal to 0. What is this D? Is it number of rooms or is it number of persons per room? That is going to be number of persons per room. See, it's not that we need to find let's say same number of rooms for section A and then same number of rooms for section B and same number of rooms for section C. No, same number of persons in every room. So that's going to be D. Now what should we do? D is a number that divides 60, 84 and 108 completely. If D is a number that divides 3 numbers completely, D must be the HCF of the numbers. Highest common factor. So what is this one? By calculation we can say 60 is nothing but 5 into 12. 12 is nothing but 4 into 3. That's going to be 2 power 2 into 3 power 1 into 5. 84, what can we do? That is 2 square into 3 power 1 into 7. 108, what can we do? That is 2 square into 3 power 3. No, that is 2 square into 3, that's it. Yeah. Now what is the HCF here? What can we do is like, we have got 2 is presented here, 3 is presented here, 5 is presented here, 7 is presented here. What is the least power of 2? That is 2. What is the least power of 3 presented? 1. What is the least power of 5 presented? 5 is not presented in 108, so that's going to be 0. What is the least power of 7? 7 is not presented in 60 or 108, that's going to be 0. So it means it is 2 square into 3 power 1. That is going to be 12. So 12 is the divisor. 12 is nothing but the number of persons. So we can directly say 12, then we get 5, 12 here we get 7, and 12 here we get 9. So 5 plus 7 plus 9. So we should have exactly 21 rooms. Minimum number of rooms, that's 21. Instead of trying to find 5, 7, 9, what we can do is like, this is 12, so it's going to be 5. This is 12, it's going to be 7. This is 2 power 2 and then 3 power 1, some part of this one, that's going to be 12. So we are left with 3 square, that's going to be 9. So 9 is the number of rooms, 5 plus 7 plus 9. Look at this one. Reading this question itself will take more time, but you need to understand this question. CAT questions are always surprising. We just need to know the application of very simple concepts. You just know how to apply the concept. Knowing the concept is not the only solution. The only solution is you should know the application and you must be able to apply it. You should know the concept, not the solution. Yeah, let's move to next question. After the division of a number successively by 3, 4, 7, the remainders obtained are 2, 1, 4 respectively. What will be the remainder if 84 divides the same number? We have a number. Successive division is quite simple. If you have a number and we try to divide with the divisor 1, we'll get a quotient 1. Now the second time successive means quotient 1 is divided by divisor d2, we'll get quotient number 3. Now the quotient number 3 is divided by divisor 3, we'll get some other quotient. So it's going to be the quotients. However, here we'll get remainder 1 here, we'll get remainder 2, we get remainder 3 and so on. Now here quotient 2, not quotient 3, it's quotient 2. Now what this one is, we have got after the division of the number successively by 3, 4, 7, so these are the divisors 3, 4, 7 and these are the remainders 2, 1, 4. Now the first number that we can find quite easily, that is 4 into 4 plus 1, that's going to be 4 into 4 plus 1, and the whole thing is again multiplied into 3, that's plus 2. So 4 into 4 is 16 plus 1, 17, 17 into 3, 51, 51 plus 2, 53. 53 is the first number. If 53 is divided by, let's take 53 is divided by 3, we get quotient as 17 and remainder as 2. Now when 17 is divided by 4, we get quotient as 4 and remainder as 1. And now 4 is divided by 7, we get quotient as 1 and remainder is 4. That's what we have done. So the last remainder, that must be multiplied with quotient number, divisor number 2, and the result must be added to second remainder, and the whole result must be multiplied by first divisor, and the whole thing must be, or the final must be added to the first remainder. That's what we get, 53. 53 is the first number. What would be the second number? What would be the next number? That's what we need to find. That's nothing but first number plus LCM of divisors. Here it's 53 plus LCM of 3, 4 and 7. That's going to be 84. So it's 53 plus 84k format, this number. So we have got a number. This number is nothing but this is equal to n. N is of the format 53 plus 84k. When we divide this number successively by 3, 4, 7, we get the remainder 2, 1, 4. Now what will be the remainder if 84 divides the same number? So we have got a divisor 84. What happens if 53 plus 84k is divided by 84? Then 84 by k by 84, the remainder is going to be 0. 53 by 84, remainder is going to be 53. So that's going to be 53. Successive division. The number of positive integer valued pairs x, y satisfying 4x minus 17y equal to 1 and x is less than or equal to 1000. This is what we need to find. That's what we need to find. Look at this one. This is an algebra question. This is definitely algebra question. This type of questions are frequently asked in CAT, almost every single time. However, look at this one. We are trying to solve this question in numbers. What is the correlation between numbers and the algebra sum? That's very simple. This is nothing but a Chinese remainder theorem. Chinese remainder theorem is LCM method 3. LCM method 1 is simple. We get the same remainder whenever a number is divided by different divisors. So the number is going to be of a pattern, remainder plus LCM of divisors. Second pattern is going to be we get different remainders. However, the difference between remainder and divisor is constant. So then that's constant plus LCM of the divisors. That is LCM method 2. Now LCM method 3 is different. We get different remainders. Remainders are not equal. The difference between remainder and divisors are also not equal. That's why we get. So here, if we can write this one as 4x equal to 17y plus 1. That's nothing but when a number n is divided by 4, the remainder is 0 and the quotient is x. When the same number is divided by 17, the remainder is 1 and quotient is y. That's what I've written n. So 4x plus minus 17y equal to 1. And now we need to find x. Let's see what we can do. So 4x equal to 17y plus 1. We can write like this. Now, what is the first set of solution for x and y? That's what we need to find. So when y equal to 3, that's going to be 17 into 3, 51 plus 1, 52. Then x is going to be 13. So first set of solution for x and y is equal to 13 comma 3. Now we need to find the next set of solutions. This is what we need to learn. Now what we can do is like x grows with the value attached to y, it means that its series is going to be plus 17. Y grows with the value attached to x, that's going to be plus 4. So 13 plus 7 is 30, 3 plus 4 is 7. Look at this, 4 13s are 120, 17 7s are 119 plus 1, that's 120. Now that's going to be 47 and this is going to be 11. Next one is going to be 64. This is going to be 15 and so on. Now, however, x is defined. X must be less than or equal to 1000. Now, what we need to do is like we need to find pattern for x. X is nothing but 13 plus 17a format. When a equal to 0, x is going to be 13. When a equal to 1, x is going to be 30. Now, this is less than or equal to 1000. Or we can say that 13, 30, 47, 64, the numbers are in arithmetic progression. What is the nth term? Nth term is less than or equal to 1000. Find the nth term and how many terms are there. That's it. So this means it's going to be 17a less than or equal to 987. So a is less than or equal to 17. 5s are 85. So that is 137. 17 8s. 17 8s are 136. So 58. But look at this one. A is less than or equal to 58. And also we know that a is greater than or equal to 0. So it means that it can take 59 terms. It's not 58. A equal to 0, then that's going to be 13. A equal to 58, then that's going to be closer to 1000. Carefully here. It's not 58. Look at the answer options. One answer option is 59, 57, 55, 58. It's 59 values. 59. There is every possibility that candidate can probably mark 58 even after finding the solution. Finding the solution itself is a bit difficult for candidates who haven't learned the concept. So these are the questions which are advantageous for IIT and the NIT students. Not for all of them, but for majority of them. Let's find the next one. If x and y are integers, then the equation 5x plus 19y minus 60 equal to 64 has. Again, this is the application of LCM method, which is Chinese remainder theorem. So we can write this as 5x equal to 64 minus 19y. Now here it's not plus, actually plus y, it's minus. No. What value? That's what we need to find. If x equal to 5, then it's going to be 25. Then y must be That's what we need to find. Or else you can rewrite the other way. So the writing the other way is the most useful here. What we can do is like if we write 19y equal to 64 minus 5x, then that's going to be very easy. Because we can easily find what is y here. Now what is y? That's what we need to find. So if y equal to 1, let's say, if y equal to 1, then x must be 9. That's how we can find the solution. If y equal to 1, x equal to 9. Now 19 ones are 19, 64 minus 5 nines are 45, 64 minus 45 is 19. So first set of solutions for y and x is 1 and 9. Now look at this one, y grows with a value attached to x. Careful. What would be the value? That's what we need to be careful here. So if this is what is happening, that's going to be plus 5, then it's going to be 6. What about this one? Will it grow by 19? Let's see. 19 into 6 is equal to 64 minus 5 into, if this is growing by a value attached to this one, that is going to be plus 19, then we can say it's going to be 28. Now, can I write 5 into 28? Now, 19 into 6 is a positive integer, and 64 minus 5 into 28 is going to be, what is that one? That's going to be a negative integer. So then what can we do is quite simple. What you need to understand this one is, look at this one. If this is going to be positive, then x must be negative. Otherwise, 64 minus of minus, then that is only good. That's going to be the positive number. Otherwise, it's going to be a negative number. Then what can we say here is, the first set of solution, we know that it's 1 and it's 9. Then it grows with plus 5. Exactly, it is subtracted by minus 19. So it means that y plus next value is going to be 6. Then x next value is going to be 9 minus minus 19. That's going to be minus 10. The next value here is going to be 11, and that value is going to be minus 29. Next value, it is going to be 16. That value is going to be minus 19. That's going to be minus 48, and so on. Now we just need to find. So this is the pattern of y. This is the pattern of x. No solution when x is less than 3000 and y is less than 0. X is less than 300 and y is less than 0. Do we have a solution here? Y is less than 0. Now y, we have got that as 1, 6, 11, 16 and so on. X is going to be 9, minus 10, minus 29 and so on. No solution for x is less than 300. X is less than 300 is always possible here. Now y less than 0, we need to check. Y less than 0 means it's going to be a negative number, y. It means that left hand side number is going to be a negative number. So we can write this arithmetic progression this side as well. So 1, 6, 11, 16. So we can say that's going to be minus 5, that's going to be minus 4, and that's going to be minus 9. So look at this one. There is a solution even if x is less than 300 and y is less than 0. There is a solution. So here as well we can say it's going to be 19 here. Minus 19, that it's going to be 28. Look at this one. We are trying to minus 19. So that's going to be 28. So we can say 28 on the positive side. No solution. X is greater than 250 and y is greater than minus 100. Greater than minus 100. X is greater than 250. There is a solution, right? X is greater than 250. That's going to be a huge number. That's going to be 9, 28, 28 plus 19 and so on. Now y is minus 100. There is a solution. So because y is just the difference is 5, 5, 5, 5. X is like just a huge number. Then we can find a solution here. A solution for x 250 to 300. There is always a solution because the x differs only by 19. So we can find some number between 250 and 300. Now we just need to find whether there is a value possible for y between 59 and 56. Now it's going to be minus 9. So then it's going to be minus 14, minus 19. So this value is going to be minus 14 minus 19, minus 24, minus 29. So look at this one. Y could be a number ending with 4 or ending with 9. Where is this number? Look at this one. It is between 59 and 56. It is not considering minus 59. Had it considered minus 59, then we need to find the other answer options. So here it clearly said that. Now, can we say that there is a solution for this one? No, there is no solution. There is no solution, but it clearly mentioned there is a solution. No, there is no solution. Here, it mentioned that no solution, but we can see that there is a solution here. It clearly mentioned that there is no solution. We can see that there is a solution here. It mentioned that a solution for 250 to 300. Yes, that's it. There is a solution. Look at that one, answer option A and B. Whenever there is a solution, it mentions that no solution. But answer option D, we know that there is no solution for y lying between 59 and 56, but it mentioned there is a solution. That's why answer option D is also incorrect. Look at this one. This is not exactly Chinese remainder theorem. Chinese remainder theorem is quite simple. N divided by some number, we need to find the remainder. But the divisor is complex number, so we divide the divisor into multiplication of 2 or 3 numbers. The 2 or 3 numbers are very known to us. All those numbers, all the divisibility rules of that particular numbers are known to us. Here what we have learned is like, what we're trying to do is like, we're trying to apply whatever we have learned in Chinese remainder theorem. Of course, without Chinese remainder theorem also, you can just learn all these simple integral solutions of these numbers. That's very easy. But however, you can just identify it quite easily. This, I can say, is a very, very important question. And I would say that since it appeared in CAT and it's a very complex one, or it's a time consuming one, if you don't identify the pattern, so I would say that it's a very difficult question. Look at it's really impossible for a lot of students because they have no idea how to solve this question. Even if they know how to solve this question, they are really very scared about the answer options. That's it. Let's see, we'll solve the final question. Now the number of solutions of the equation 2x plus y equal to 40, where both x and y are positive integers and x is less than or equal to y. There are two conditions here. They are positive integers, that's very easy, and also we need to find x is less than y. Now what we can do is like 2x plus y equal to 40. Instead of taking y to other side or 2x to other side, what we can simply do is like y maximum value is 40 because it's going to be positive. Y minimum value is going to be, can we take 1 here? If I am taking 1 here in place of y, then 2x plus 1 equal to 40, then 2x equal to 39. X must be a number, but that's not an integer. So in such a case, y value is going to be 2. So y is even number, x is any number. Now 40 is this maximum and 2 is the minimum. When this is maximum, x is going to be 0, so that is the minimum value. When it is going to be 2, x is going to be 19, that is the maximum. Now we need to find the number of solutions, just like that. So it's going to be 40. If y equal to 40, then x equal to 0, that is not possible because it's both x and y are positive. So it means that y is going to be 38, then that is possible. Now 36, 34, 32, 30, 28, 26. Should we write all these things? No, we need not. We can just like write all of them. 22, then 20. If y equal to 20, then let's take 18, 16, 14. Now if y equal to 14, that is where we need to see x. If y equal to 14, then 2x equal to is going to be 24. If 2x is 24, y equal to 14, 2x is equal to 26, so x must be 13. So here x is going to be 13. What happens if we take, it's going to be 12. If y equal to 12, then equation 2x equal to 28, x equal to 14. So this is ruled out. So up to this one. So it means that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 values it can take. It start from 14. If y is going to be 12, then x is going to be more than y, that is ruled out. Can we take 13 in place of y? No, that is not possible. If you take 13 in place of y, x is going to be not an integer. So 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38. So 13 numbers are possible. 13 solutions. Look at this one. It's very, very useful to know how to apply Chinese remainder theorem. So with this one, I finished Chinese remainder theorem, constant remainder theorem, least common multiple 1 and 2. The next one, we are going to learn Fermat Little theorem, Wilson theorem, Euler number. So once we finish these next three, then all the remainder theorems are going to be finished. That's it. So these are the years in which these 13 questions are asked in CAT. I don't find any question after 2008. 2009 and onwards, we have no access to the papers. We have limited access. All the papers available after 2008 are based on memory. Students who have written or faculty members who have written from different universities, they've remembered the questions and then that's it. So I cannot really believe all those questions. But do remember, these LCM questions are frequently asked in CAT. Thank you. Next session is going to be about Fermat Little theorem, Wilson theorem, and how to find the remainder by using Euler number. They're very important. Thank you.